So how many of you have seen Frappe Cloud before? Just a raise of hand, used self-hosted, whatever. Okay, almost half the people. How many of you tried self-hosting? Okay, 10 or so people. And the rest basically are here, they're trying to hope something interesting happens. How many of you are hoping that this is a feature where I release containers on Frappe Cloud so you can run arbitrary stuff? Okay, just one person, so good. Not a lot of expectations. So just a general idea about what Frappe Cloud is it's a dashboard on top of some complicated Linux command that you have to run if you have to run Frappe applications, right? So if you go self-host, you can download Frappe Docker, you can download the Kubernetes charts, you can run the standard installation process, or you can come to us and we will essentially just give you a UI, and you don't have to worry about any of the Linux commands. And then some of these things are very easy to do, some of the things are very easy to slap a UI on top of, and some of the things are kind of hard. And in the end, you just get like a very small, just one-click button, but a lot of work goes into building that button. And some of the times it is very hard, like very easy. The UI seems extremely complicated, but in the backend there is just one simple command running. So the complexity varies, whatever. So what I'm trying to do here is now, because of customer feedback, customer demand, people have been asking essentially, hey, sure, you guys run Frappe, and you guys can help me run the latest version of Frappe, my custom apps, whatever. Can I run containers, right? Can I run arbitrary stuff on FC? And so FC is again Frappe Cloud for those who haven't heard before. So this demand keeps coming over and over again. And last conference also, I think promised people, hey, we'll release these containers features, but it didn't get released. And one of the complications, again, this is me post-hoc justifying my ineptitude or just stupidity, is we didn't release it because I was essentially just over-engineering the feature too much because we weren't using it internally, right? And so this is how Frappe Cloud looks internally. We have one main server that you guys access, and then that server essentially controls a bunch of other servers. We have roughly 500 of these lying around, and then some people run their own clusters. That is just extra. So to do this control, what we do is we have something called Press and Agent. So Press is a Frappe application. If you guys have ever seen it, just another Frappe application. It has few things here and there that it does differently, but looks like any other app. And Agent is a Flask application because SQLite just didn't work on Frappe before, so we wanted it to have a very low footprint, but have some database and some tracking. So what Agent does essentially is Press says, hey, could you please run this command for me? Could you please do ls? Could you please do rm? Could you please do docker run? Could you please do MariaDB backup? Could you please do apt install something, right? And this communication happens over HTTP. Basically, every single command is sent over HTTP, and Agent just executes it and sends the result back. Sometimes the commands take longer, so Agent essentially says, hey, here is a reference token for you. Please come back a minute later, 2 minutes later, and ask me for the response, and I'll give you the response. So not a lot of work, just some synchronous, asynchronous command execution. That is all Agent does, and it tries to put some simpler wrapper, so the code does not look extremely complicated. I'll give you some idea about how Agent looks. And eventually, this is the crux of the communication between, on Frappe Cloud. This is the thing that is different than anything else you have ever seen. And it's not a lot. Anyway, so what Agent does then essentially runs some command. So every time you say, hey, could you please deploy a bench for me? We run something equivalent of bench in it. When you say, hey, give me a new site, we run bench new site. Very straightforward, nothing complicated after that. So when we run sites, things get slightly complicated. You typically would run one server. You just run one server, and you run MariaDB on the server, Nginx on the server, the Frappe applications on the server, and everything is straightforward. We run a bunch of other servers. So I'm just going to ask you guys do you guys think that we run MariaDB somewhere on Frappe Cloud? Yes or no? Just raise your hand if you think we run MariaDB somewhere on Frappe Cloud. I'm just asking a question, say yes, no. Okay, yes. So obviously we run MariaDB, like the whole Frappe, all of the Frappe sites run MariaDB. We run roughly 500 MariaDB servers. Do you guys think we run Elasticsearch somewhere underneath on Frappe Cloud. Elasticsearch is this fancy log searching app. Okay, apparently we do. So all of the logs that you guys see, all of the metrics, analytics on-site dashboard are essentially powered by Elasticsearch. Do you guys think we run Prometheus? Okay. So Prometheus is again this time series database where we essentially keep pinging every one of our servers, collect metrics. So when we have to show you dashboard, Frappe Cloud dashboard, that is where we collect the data from. How many of you think we run ClickHouse? Okay. Okay. I expected this. We don't run ClickHouse. I was just checking this if people try to be smart. Anyway, we don't run ClickHouse. We were planning to, but we don't. So anyway, so the idea is underneath Frappe Cloud is slightly more complicated than typical sites. So this is how an app server on Frappe Cloud looks like. We run multiple benches on one server. Some of the times, all of these benches belong to you if you have a dedicated server. Some of the times, we have a server, and then you just control the bench. All of the files attached to that bench, basically sites directory, all of the private files, public files, your site config, everything resides on one single file system that is attached to the server. And everybody just gets a small chunk of this file system. Very straightforward, the way you would do it anywhere else. And when we run MariaDB or any other service for that matter, what we do is we just ask the server, hey, what is your private IP address? The server essentially has a private IP address that is attached to the life cycle of the server. So every time you start the VM, you'll get a different IP, but otherwise the IP stays the same. And we essentially rely on that fact heavily. So everywhere internally, like going in all of these fancy ways of Kubernetes and everything, where you run DNS and DNS then points to IP addresses, we just say, hey, just remember these IP addresses. And in a lot of cases, we just do convention. So all of our IP addresses have particular pattern. So if the second last octet ends with 3, we know for sure that means a database server. If it ends with 2, we know for sure it is an app server. And typically the app and database server pairs have the same IP address. So if it ends with 101, the database server also ends with 101. If the app server ends with 127, the database server also ends with 127. So we try to keep it as simple as we can, and then without having a lot of hierarchy in the network, because I didn't know any better. And eventually we made this slightly complicated. So in the old model where the app server essentially has the file system attached to the server, we now have database server where the data actually resides on EBS volume. So we can move this data between 2 different machines whenever we need, but we can't change the IP address. So these are some of the problems that you face essentially if you start making your application like a caveman, and don't pay attention to any of the fancy stuff that is coming in the market. It helps us a lot because we don't have to deal with any Kubernetes complications that most of the people that we have seen deal with. But what we are trying to do now is we are trying to solve this problem for us. So one of the problems I've seen so far is Frappe Cloud is growing very, very fast. The demand is growing. And the demand is just not on the resources, it is also on the feature set. So people are asking more and more complex features. And we also have an ambition where we want to do more work, more deeper work. We want to add more metrics, logs, anything that essentially makes cloud much better than what it is right now. And that needs engineers, and that means now instead of one engineer building this for first 2 years and then 3 people later and then 5 people later, now we have 10 engineer team. And it's extremely difficult to make sure that everybody knows everything on this stack. So even full stack, so when Frappe says full stack, what they really mean is, well, Python and JavaScript, that is what we mean. Like it is not Linux kernel and the front end and everything that Suraj does, right? So eventually our engineers have specializations, and what we want to do is we want to cut this huge monolith that I have built into pieces where somewhere down one part of the monolith essentially will be people who have Linux expertise, container expertise, disk operating systems, whatever. And the people above this layer will have managed layer expertise. They'll be database experts like Tanmay. They'll build Frappe specific features. So the idea essentially is not new. This is just copied from a lot more other systems. One of them is Nomad. Nomad does some of this very well, except they just went this BSL route. The idea is you have containers. Containers basically are a simple process. So every time you run apt install something, you are typically running a process. So container just put this process in some boundary. Okay, how many of you have no idea what containers are? Like no idea whatsoever. Okay, 2, 3 people. How many of you have heard the word before? How many of you have heard Docker, Kubernetes, Podman before? Okay, most of you. How many of you have run containers on your machine, like knowingly, like Docker run on your machine, not accidentally? Okay, a lot of people. Okay, so people know what containers are. Okay, so somehow they make it extremely easy to ship and deploy applications, right? The complication happens what after, what after you have built the application and now you have to deploy it. So one of the complication is essentially the operational complication, which is how do you make sure now your containers have the correct networking available to them and correct data that they have access to. And the data remains with them wherever they go. So even if you stop the container, the data stays around. If you move the container somewhere else, the data goes with it. That is the complication. And people just try to solve this problem by just slapping Kubernetes or Nomad or any other orchestrator on top. We decided not to go that route. So this is how I'm trying to solve this problem, by building our own abstractions, like as modestly as possible, not trying to do anything complicated. So the general idea I'm going to do is I'm going to build something, some abstraction, some doc type for containers, and then we will try to essentially run containers with this doc type. While doing this, I'll show how we do stuff, how we do things on Frappe Cloud. So you'll get to see some idea of how communication happens, and some idea about how we do AWS-related operations. Again, none of this is complicated. This is just very hairy. That is all. None of this is smart or intelligent or anything like that. So I have wasted 10 minutes on talking about the talk. Let's just go into the implementation. So you guys have run containers, and the next immediate step after running containers is essentially just putting 2 containers together so that they can talk to each other, and hopefully not the rest of the world. So the way we do this is we'll just go to commands and we'll see how we can get this done. So just give me a second. So before moving forward, there is this other idea about containers is typically any service. Like this is WordPress's description of how WordPress runs just 2 services, database and the WordPress app. So the database essentially says, hey, run a particular image, maybe run a specific command when you're running the image, store my data somewhere, and have some environment variables. Maybe I want to set a particular password, I want to store some secret, whatever, some environment variable so that on demand I get some random value. Maybe this is going to be a random character as well. And expose my, so I listen to port 80, for web services I listen to port 3306, make sure the other containers can listen to it. And so the containers inside this network can talk to each other anyway, but make sure the rest of the world can listen to me, because just talking between 2 containers is useless. Somehow you have to send traffic in and out. And that is generally what you have to implement. If you implement this much, you are more or less set. And one of the ways to do this is just copy this file, store it somewhere, and run docker-compose up. How many of you have heard of docker-compose? Okay, good. So one problem with docker-compose is there's just no way to scale it beyond 2 machines. And I don't mean this whole magical scale of, hey, running thousands of copies of every application. The idea is basically, what if, your machines are just small enough, say 4 gigabytes each. You can't basically say, hey, please run one container on one machine and the other on other machine. For whatever reason, you cannot do that with Docker-compose. It is built for developers, so all you can do is just run all of the things on one machine. What we're going to do is we're going to implement a similar strategy, and at some point in time, we'll say, okay, what part of this has to change so that this same technique will work on multiple machines. So, by the way, thanks for being quiet. I've been at the back for the rest of the talks, and you guys have been very attentive so far. So, I've just gone ahead and made a doc type for us to refer to before we do this. I just call the doc type container. It has all of these fields. It has an image field. It has a server field to tell where the server lies. It has a command field. Whatever we have seen so far, it just implements all of these in fields. So nothing fancy here. So this is what we do on Frappe Cloud. Instead of running commands manually, we just try to put in doc types and then make sure now you can run automation on top of these doc types. So again, nothing fancy, nothing new. Maybe we'll face some errors while doing this. And what I've done is again taken the same docker-compose file that we saw before and just try to pre-fill the fields so that we don't end up time copy pasting. I will left the storage part, which we'll implement later. So again, everything same, nothing fancier. And in the backend, okay, this is a good enough font for everybody. So the way Frappe Cloud essentially does communication with the servers is we call a method called agent.something. So in the end, we have some definition of agent. It's just a class that basically says, hey, there is a Flask app running on the server. This is just a wrapper to send requests to the app. And we have two methods, agent create container and agent archive container, and that's it. And the way these methods are implemented is again very straightforward. They just essentially take the data that we have stored in the doc type, put them into JSON and say, hey, that's it, just do something with it. This create agent job is a wrapper for Frappe get doc. What we do is we have another doc type that essentially tracks all of these jobs that I talked about before statefully and says, okay, where are we so far? Are we running them? Are we waiting for them to execute? Whatever. So all this create agent job does, it creates this doc type and then sends the request to the agent and just waits. That's it. And the doc type is again very straightforward. Just has some references to what you are doing. Has some reference. So in some cases, we send some payload. For instance, if you have a create container call, you have some config about the container that we are going to run. So in this case, we are going to send the image that we are going to run. So basically the same doc type we saw, we're going to send it as is to agent, and agent is going to do something for us. On the other side of this puzzle, the way we implement this is again very, very straightforward. Flasky is we have a webpy file, and we just implement Flask endpoints. Let me just do webpy. Okay. So we have a get container method that has a particular route. We have a create container method, again, with some routes. And it is not going to be very surprising to see the implementation of these is again very straightforward. Just says, okay, just do some initialization called .start because we want this network, create the network. We'll go into the detail of what the networks is. I'm just trying to get over this idea of what this weird piece of code is, okay? And then we just call some methods. This weird decorators that you see at job, at step, is essentially how Frappe Cloud keeps track of what function, what step we are running. So it's not like we run a MySQL command and then for 30 minutes we don't know anything. We kind of know which step of the backup we are in. And then if you say container start will look very familiar to you. It essentially takes all of these arguments, puts them into some command line, hyphen name something, restart something, detach something, hostname something, and eventually just calls docker run on the command. That is it. Nothing fancy. Okay. We'll try and get some idea about what these which of these are useful, which of these are kind of superfluous, and so okay. Just to get some idea, how many of you think so far we are doing something extremely weird? Like, okay, nobody. So everybody believes this is just a straightforward, just putting some doc type on top of Docker. That is it, right? Nothing weird. Okay, that is literally what it is. And archive container is again the same way implemented. We're just saying, hey, Docker stop the container, Docker remove the container, and that is it. So the complicated part is this Docker network, attachable subnet, driver bridge, something. So typically when you go to a machine, say I have a machine here running on AWS. Let's hope it connects. So it is not running any containers. And if you run something, you find an old command that is very straightforward. So in this case, I'm saying, hey, run this machine. use this hyphen name flag, this hostname flag, and just run this Ubuntu net image. Okay, this is just a stock Ubuntu image. Maybe I'll just do some so everybody can see. Okay, this is the command we are going to run. Okay, very straightforward. Everybody of you has done it so far. No idea. Nothing weird here. Okay, great. Okay. So the whole this name, hostname, and name things do is essentially it sets a good name for the container, and this is what you're going to use. This is what Compose uses underneath. So if you don't use these flags, for instance, what ends up happening is you will get a random name for the container. Okay, your shell look like something random. Okay, and again, this might look like a cosmetic difference, but it is not. For instance, what happens is if you run two containers, let's say we're going to run this with the old name f11. Okay, let's just call it f1. Let's not make it complicated. And we're going to run Ubuntu bash and just let it run as it's nothing. We're not going to run anything. We're going to start another container. So, okay. We're going to call it F2. I'll zoom again. Okay. So we're going to install. So by default, the Ubuntu images don't contain anything. They don't have ping. They don't have IP commands. Nothing. So we're just going to update them. I had a ready-made image. It just went away. So we're going to install two packages, and we're trying to ping. So these packages will give us ping and IP command. So IP will essentially give us idea of who we are, and ping will give us idea about who would just ping some other container. So if I do ping F1, like any idea what happens now? I will just run the containers with RM name. There is no network or anything like that. What do you think happens? Anybody? Okay. Yeah. So this is what happens right now. So if I do ping F1, it basically says it doesn't exist, right? Yeah. So these two containers essentially are running on the same machine, but they are kind of isolated from each other. Right? This is what we want for isolation, but this is not good for us, right? Because if one of these is say called WordPress and the other one is called DB, they can't even talk to each other. You can guess the name of the other one. The first one is going to be 172.17.02. If we try again, the IP address came from this IPA command, which basically says, hey, show me all the IP addresses that I have. IP addresses are attached to this container. And this is our own IP address. And we can obviously ping ourselves. That is supposed to be possible, okay? No trick there. If I do 2, I'm technically able to ping the container, okay? I just don't know about it, right? That is the idea, right? So on this machine, the way the networking is configured, that they are able to reach each other, but they just don't know about their names. And that is a very simple trick, right? Otherwise, everywhere in your config, you'll have these random IP addresses spread out, and we don't want that. So the way we'll solve that problem is we'll just create a bridge network, like this gentleman mentioned. So Docker network ls, sorry, okay, do I have to come out? Exit. So Docker has very straightforward looking commands. If you do a Docker network ls, it'll give you what networks already exist. I was just testing this out with WordPress net. We'll create another network. So Docker network create is how we create a network, and you just give it a name. So say demo ping, and you get a random IP, a random address. Again, if you do Docker network ls, the name will be here. It is a bridge type of network. We don't really care what that means for now. The only change we're going to do is we're going to run these containers again, and this time we're just going to add one more extra flag here saying net is equal to demo ping, right? So we're essentially saying, hey, when you run these containers, attach it to this bridge, whatever this bridge is, right? And that is the only difference, right? Again, this one doesn't have IP or anything. This container doesn't either. So we're going to do one trick. We're going to do docker commit. So docker commit is this idea that whatever the live container that is running, right, you want to keep the state as is. We just install apt, some apt packages here. If we just exit the container, the packages are going to go away, right? That is the whole idea of immutability on image level. So we're going to say, hey, just do a little bit of trick and commit this container as it, and we will call it Ubuntu committed. Okay, and we'll also add a -p flag that basically says just freeze the container before you take the snapshot. So if you do docker image ls, you will see this extra image that we just created 6 seconds ago, right? So the only thing that it has is this extra package, okay? So that we don't need to apt update over and over again. So we'll do exit, we'll do the same thing we did above. We'll add a -net flag, demo ping, and instead of Ubuntu, we'll run Ubuntu committed, okay? Because we'll get those packages back, right? So far, no questions, right? Everybody has, and we'll run the container that was running before as well. Ping F1 in the frame above, ping F2 in the frame below. Now, if I do IPA, I get roughly the same address that I was running, slightly different. So remember the last time we got 172.1.7. This 1.8 is essentially the address of the bridge, right? Again, it doesn't matter, but just an idea that you should know about. Now, if I do ping myself, this is my IP address. I can ping myself, obviously. If I do 2, again, this is guesswork, but it's going to be the IP address of the container above. I can ping it, right? If I can ping F2, which is my host name, I can ping. And if I do ping F1, great, like this is what we want, right? This is like very, very simple trick, but this is what we want. We're going to use this trick so to get rid of this IP address problem. Okay. Great, so this has been just a lecture in Docker networking. How many of you are confused so far about what is happening here? Okay, everybody understands what is happening. How many of you think I'm going way too slow? Okay, some people are like, okay, this is just boring. Move it along. So, what we're going to do is now just we're going to get rid of, we're going to go back to our doc type. And again, so I'll show you the create container commands, create container function and everything. Just do the same thing. They create a Docker network with some extra flags. They add subnet flag, they add this bridge flag. But otherwise, all they are doing is just piping the input of the JSON that we are passing around into these commands and trying to create a network and attach containers to the network. And so here, what we're going to do is we just got rid of this WordPress and I'll delete them. So I'll just duplicate them first. And then delete them. We could have deployed again. So we'll give it a name again, WordPress. And this name is important again because like we saw, the name of the container matters. This is how we ping. So we're going to spawn a WordPress container. It's going to have this IP address. We can change it if you want, but it doesn't matter. We're going to create a fake network, WordPress net, with this name. We'll just call it WordPress net. Okay, that's fine. And we're going to save. So when we save, essentially, we're going to call this deploy method, which is going to compile all of this JSON, send it to agent. Agent is going to run the command for us. And if everything works, the status from pending is going to change to something else very soon. Okay, it hasn't changed. So this is some debugging idea about how Frappe Cloud people do debugging. You just go and look at error log doc type and see if there is anything there. It is okay. Nothing recently. Okay, the job is finished. I just should have waited longer. That's it. So the job automatically completed. I wrote a hook that basically says when the job completes, please come back and change the status of the WordPress container. So now, if you go on the host again, whatever we did, whatever we copied from the Docker Compose file, we should be able to see a container here that is essentially just running WordPress. Okay, this Ubuntu, just don't pay attention to the Ubuntu image. We are running WordPress, we are doing this port mapping, and we're going to do the same with the database container. How many people think that there is some mysterious thing that is going on here that needs to be explained? Okay. Again, I'm going to just duplicate this. I don't want to fill up the fields again. And I think the names are unique, so I'm going to delete the DB container here. So again, in this configure environment variables, it essentially refers to the WordPress. The WordPress container refers to the database server, database container with DB. So that is the name we want to keep. We want to keep it as draft and save. Again, it will take 5-10 seconds for this to run. We'll go back to the machine and do docker container ls. Eventually, we should see a MariaDB container running with the name. Keep saying restarting 1 second ago, DB. So basically, every GAN that I gave about how containers work and how network work, we just translated it to some Python command, nothing fancy. And hopefully, if this is fine, what we should be able to do is we should be able to do listen to this address directly, go to a browser and hit the address, and then hopefully we see WordPress. But it's not going to happen, right? Because of this weird thing. Like this address is not routable. Like you can't reach this address. So what we're going to do, and this is how we do everything on Frappe Cloud, is we have this nginx-conf file for every service. Okay. How many of you have heard of Nginx or operated Nginx before? Okay, some people. So the general idea is essentially Nginx is just a proxy that says, okay, if we send HTTP request my way, and if you give me a config, I can do weird stuff to those requests. I can send them some other way. And then it has a bunch of very verbose config. So this is essentially how we operate agent. We say, okay, hey, anything on this /agent endpoint, please pass it on to this other internal IP address, okay, that we can't otherwise access. So what we're going to do is we're going to write a similar stanza for our containers. Otherwise, we can't access them. So I just wrote a ready-made stanza that is hopefully going to work. So some of these look very verbose, but we're just going to. So the way this works is essentially we're saying, hey, on this server, wherever this machine is running, /endpoint, which is basically just the name of the server. If somebody hits, send the request to this IP address, okay? And this IP address happens to be the IP address of the WordPress container. And the way you would check that, I mean, we know it because we have just created the container and we set the IP address in the container doc type. Somewhere here, we set it to 10.3.101. 10.3.0.101. But if you can also do something called docker inspect. And this is Docker's way of saying, hey, give me idea about whatever it is. Like if you're reference here, and it essentially throws some JSON output back to you. So this one basically says, hey, it seems like you are running WordPress container, and this is the state of the container, like bunch of verbose JS that we don't need to worry about, but at least we have the good idea. We have good idea, and eventually it will tell you what the IP address also is. Anyway, that is not relevant. So we got the IP address, and we are setting some extra variables because apparently I tried doing this before, and WordPress does not really like it without these variables. So we're just going to copy it and paste it into Nginx stanza. So the location of your Nginx config will depend on how you set it up. The way we set it up is it is in this directory home frappe agent, and the Nginx file is essentially what gets generated. So this file gets actually generated from a template, but for now we're just going to bypass the template generation and say key. So we listen to for a bunch of services on each machine. So I've already done this, by the way. I pasted the same stanza here. So if we know the address of this machine, we should be able to, this is the address of the machine. This is globally routable. We should be able to hit it and see WordPress. And that is basically how you start from running containers and essentially exposing them. So what we just did, this extra Nginx stanza part, is in the complicated orchestration world is called ingress. You have to do more things for you to get it right, but essentially what it means is from outside the world, from the internet, somebody's going to hit this URL, and they're going to send traffic your way. And then you decide where the traffic goes, and you make sure the traffic goes to the correct one, the correct container, the correct route, the correct HTTP port. That is basically it. If somebody wants me to walk through some code, we will go through the code. Otherwise, the implementations are very straightforward. We're just listing doc types.